New type of star provides insight into the enigmatic genesis of magnetars. The universe's mightiest magnets are known as magnetars. These lifeless celestial bodies are incredibly dense and possess magnetic fields of unparalleled strength. Although they are scattered throughout our galaxy, the method by which they are created remains a mystery to astronomers. Recently, a team of researchers utilized a variety of telescopes across the globe, including those owned by the European Southern Observatory, ESO, to locate a living star that is anticipated to evolve into a magnetar. Through this discovery, scientists have identified a new kind of astronomical object, massive magnetic helium stars, and gained insight into the origins of magnetars. For more than a century, the star HD 45166 has been monitored and studied, but it remains an enigma that cannot be easily accounted for by conventional models. Beyond being part of a binary star system, it is known to be helium-rich and several times more massive than our Sun. Nonetheless, there is little else known about this stellar phenomenon. The lead author of a study on a particular celestial object published in Science is Thomas Schenaar, who also works as an astronomer at the University of Amsterdam in the Netherlands. According to Schenaar, this star has become somewhat of an obsession for him. Co-author Julia Bodensteiner, an astronomer at the ESO in Germany, also refers to the star in question, HD 45166, as the zombie star. Bodensteiner explains that this nickname is not only due to the star's unique characteristics, but also because she jokingly claims that it turns Schenaar into a zombie. Schenaar, who is currently located at the Center for Astrobiology in Madrid, Spain, believed that the solution to the puzzling nature of HD 45166 lay with magnetic fields. Schenaar had previously studied stars with an abundance of helium and understood that magnetic fields could have a significant impact on the behavior of stars. The traditional models that had been applied to HD 45166 failed to provide an accurate description of the star, which is situated approximately 3,000 light-years away in the constellation Monoceros. Schenaar recalls experiencing a moment of clarity while reading the literature, realizing that the star's behavior could be attributed to magnetic forces. Schenaar and his team embarked on a study of the star, utilizing various facilities worldwide. The bulk of their observations occurred in February of 2022, employing a specialized instrument on the Canada-France-Hawaii telescope that could both detect and measure magnetic fields. Additionally, the team referred to crucial archive data acquired by the fiber-fed extended-range optical spectrograph, FEROS, at ESO's La Silla Observatory in Chile. After collecting the necessary observations, Schenaar tasked co-author Greg Wade, a renowned specialist in magnetic fields present in stars at the Royal Military College of Canada, with analyzing the data. Upon receiving the results, Wade's affirmation matched Schenaar's intuition. "Without a doubt, this entity possesses a magnetic field, my colleague. Schenaar and their team made a significant discovery about HD 45166, as this star has an abnormally powerful magnetic field. In fact, their reading of the field yielded a measurement of 43,000 Gauss, which makes HD 45166 the most magnetic gigantic star discovered as of now, too." The astronomer Pablo Marchant, who co-wrote the paper, further elaborates that the magnetic field extends throughout the entire surface of the star, with a strength almost 100,000 times greater than Earth's own magnetic field. This discovery is especially noteworthy since it marks the first ever finding of a massive magnetic helium star. Schenaar expresses their enthusiasm for this discovery by stating that it is exciting to uncover a new type of astronomical object and that this star has been hiding in plain sight all along. Furthermore, this discovery offers insight into the genesis of magnetars, which are deceased compact stars possessing magnetic fields that are at minimum 1 billion times more potent than the magnetic field found in HD 45166. The estimates made by the research team imply that this star is destined to become a magnetar as it nears the end of its life. During its gravitational collapse, the magnetic field will intensify, and the star will eventually become a highly condensed core that boasts a magnetic field of roughly 100 trillion Gauss, 3, the strongest form of magnetism known to exist in the universe. According to Chenard and his colleagues, HD 45166's mass has been re-evaluated to be lesser than what was previously assumed. It has been concluded that the star's mass is roughly twice that of the Sun. Additionally, the team has discovered that the binary system in which HD 45166 is located has a far greater orbital distance than previously estimated. Through their research, it has also been determined that HD 45166 was formed through the combination of two smaller stars with high concentrations of helium. Bodensteiner stated that our understanding of HD 45166 has been completely transformed by our findings. Addendum. In this passage, it is important to note that the reference to HD 45166 pertains solely to the star that is enriched with helium, rather than the binary system it belongs to. The magnetic field that has been recorded in a star that surpasses the Chandrasekhar mass limit is a staggering 43,000 Gauss, the most potent magnetic field ever recorded. If a star exceeds this mass limit, it has the potential to collapse into a neutron star, and magnetars are a specific type of neutron star. In the context of this passage, the term billion is defined as a numerical value consisting of 1 and 9 zeros, while the term trillion is defined as a numerical value consisting of 1 and 12 zeros. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.